All right. Happy Wednesday. Um, Time is moving right along. And today we're going to learn about tuples. Okay. And then tuples are in some ways similar to lists, but they're distinct from lists in that they are immutable. And that gives it some special kind of properties. And so I guess the lecture is titled tuples, but it's maybe a better is like tuples versus lists or something. So we'll do a lot of kind of comparisons between these things. Okay, so so as far as the data structures we've really talked about in depth, we have lists, we have dictionaries, okay, and now we're introducing tuples. So tuples, they're kind of like lists in that they can contain different types, and they are in order, and tuples preserve their order. Okay, tuples are different from lists in that they are immutable. So unlike a list, you cannot modify values in a tuple. You cannot append values to a tuple. Okay, so again, you kind of think of a tuple is created in memory, and once it's created in memory, it's set. Okay, if you want different values in that tuple, you have to create an entirely new tuple. Okay, you can't. Once a tuple is made, it's like etched in stone. So it's kind of like the difference between writing in pencil versus pen. Okay, so if you want something that kind of is permanent and not changing, and you can kind of rely on it to be the same when you look at it later, you write it in pen. Okay, if you want something where you can kind of change values and update things, you'd use a pencil. And so lists are the kind of the cases where you'd use a pencil and you want to be able to update and modify values later. Tuple is when you say, hey, no, I want to use a pen. I want to use a Sharpie, a permanent marker for these things. Okay. We create tuples. You can just, this is the default. If you just provide values separated by commas, Python is going to interpret that and understand that as a tuple. Okay. And then you can also explicitly create a tuple by using parentheses as well. So here, I'm creating a tuple by doing, let me clear all of my outputs here. Okay. So I'm creating a tuple here. I've got 0, apple, 2, cat, dog, 5, and 6. Okay. And I picked these words because apple is the first letter of the alphabet, so it's in index position 1, and cat is the third letter of the, or C is the third letter of the alphabet, so it's in index position 3. Okay. Anyway, so here's our tuple. This is what a tuple looks like. Okay. Here, I am creating an entirely new tuple. This is an entirely new tuple. Here, let me just kind of demonstrate. And if I say, hey, what's the ID of this tuple right here? I get this one. And I'm pretty sure if I do this, I'll get an entirely new ID number. All right, so these are two, even though they have the same contents, they are different objects. Okay, and then now that I called both of them T, I don't know if I have a way to get back to this this one that I created earlier. Okay, I've just created an entirely new tuple here. Okay, you can also create a tuple containing one value by having a trailing comma. So here I can do a followed by a comma, and if you print this out, it comes out, and this is a tuple. Okay, and you go, well, do I need to have the trailing comma? Yes, you do. Okay, so you can see this is a tuple. The length of this tuple is 1. If you don't put in the trailing comma, Python is just going to kind of ignore the parentheses here and just say, oh, this is just a string. Okay, so here, this is it just sees this as the string A. Okay, and over here, I'm creating a tuple where I have the trailing comma. Okay. Just like the function list and the function dictionary or whatever, you can create tuples. You can kind of try to force some other object to become a tuple by wrapping it inside the function tuple. So, so here I'm creating an empty tuple. Okay, that's an empty tuple, and then here I can take something like this is a string hello. What would happen if I put this inside tuple? What am I going to get? The length of the resulting tuple will be length 5, right? It's going to take each character in hello, separate them out as different elements within the tuple. Okay, and so that's what we would get. If you want it as one word hello, okay, then you'd have to do hello, comma, and then this will understand that this is a tuple containing the string hello and not separate characters here. Okay. Similarly, if you do the same thing with a list, list on the string hello will separate them out. Okay, and this is a list and this is a tuple. And so again, pay attention to little details. Python always kind of lets you know what kind of object you have by its output. And so when you see this with the parentheses, you know it's a tuple. When you see this, you know it's a list. Okay, you put this, now you get a list containing hello in there. All right, range 5, what are we going to get here? If I wrap the range object, range 5 object with tuple, I will get a tuple containing what's range going to make? 0, 1, 2, 3, 4, right? Okay, and then we put that inside a tuple and we get exactly what we would expect. And then here I have a list containing 1, 4, and 7. And then I'm saying, hey, take that list and turn it into a tuple. And so we get a tuple containing 1, 4, 7, right? So probably you wouldn't ever write this yourself directly, but you might have a list stored as a name, and then maybe you want to convert that object into tuple, and you just take the name of that object, throw it into tuple. Okay. The same kind of indexing rules that apply to lists and slicing that apply to lists, those apply to tuples as well. So here I'm creating a brand new tuple. What is index position 1? I'm going to get apple. If I slice from 2 through 5, I'm going to get what? 2, cat, and dog inside a tuple, and I've sliced that out. Okay, and this is an entirely new tuple as well. Tuples are immutable. They cannot be modified, and so here, this is just an illustration. I've got 2 lists that are, or I'm not two lists, two objects. One's a tuple, one's a list. Their contents are pretty much the same. Okay. If you say, are they equal? They are not. Okay. The contents are, but one's a tuple and one's a list, so they are not equivalent to each other. Okay. Obviously, if you do is T L, it's obviously not, because they are definitely different objects. Okay. With a list, you can change the value. You can update values. So I can say, hey, for the list index position 0, let's update it to 100, and that works just fine. Okay, the index position 0 gets updated to 100. Okay, if you try to do something similar with the tuple, you get an error. All right, it says, I think it's going to be a type error. It's going to say you're not allowed to do this. Okay. Tuple doesn't support item assignment, saying basically this object type, the tuple, index position 0, doesn't support this thing that you're trying to do. Okay. We have methods that do modify lists in place, like list.append. So if I want to take the list, I can tack on x to the end, and we have that. If I try to do something like that, it's going to tell me that tuple doesn't have this attribute, or basically this method, this function called append. So I'm going to get an attribute error here. It says that's not supported by a tuple. Okay. And again, tuples are immutable. If you ever want something different, if you want the values in your tuple to be different, you just have to create a brand new tuple. Okay. So you replace one tuple with another. So if you want, if I want to change kind of this first item from 0 to something else, I can take a new tuple. This is a tuple containing the letter A. and then I'm going to slice from index position 1 to everything else in the tuple, and I can just kind of append these together using the plus operator. Okay, and that's fine. All right, but this, again, whenever you do something like this, this just creates an entirely new tuple. Right? Relation operators like greater than and less than and whatnot, they work with tuples and other sequences and stuff. And basically, Python just compares the first element with the first element from each sequence. If they're equal, then they go to the next element and so on. All right, it's kind of like you know, if you have words and you have to alphabetize them, how do you do it? You look at the first letter. A's come first, and then B's, and so on. And then if you have multiple words that start with A, you go to the second letter and you compare them. And if the first and second letter match, then you go to the third letter, so on and so forth. And those kinds of rules also apply here. So if I compare 0, 1, 2, and 0, 3, 4, and if I say, hey, we have to put these in order, okay, where the zeros are tied, but over here the 1 is less than the 3, so this tuple is going to come before this tuple. So this is going to be true. Is 0, 1, 2 less than 0, 3, 4? Yes, that is true. Okay. Here I have 0, 1, 2 million. Is that less than 0, 3, 4? Again, it goes in order. So 0 compared to 0, that's a tie. 1 compared to 3, 1 is less than 3, so that's true. Once that happens, it doesn't care that this is 2 million and this is 4. That doesn't matter. So this is going to become also still be true. Here I've got 0 versus 0. And then I have 500 versus 3. This is not true anymore. Okay, 500 is greater than 3, so this will evaluate to false. Okay, and so you could imagine here I've got, like, if I have words ABB, ABC, and ABCD, and I said alphabetize them, this is kind of the order that we would get. And similarly, if I turn these into tuples, ABC comes before ABCD, and so the tuple ABC comes before tuple ABCD. Okay, so the length 3 tuple is comes before the length 4 tuple if these 3 elements are the same. Okay, now if I replace this last character with D, then this becomes false. Okay, even though this is length 3 and this is length 4, because if we were to alphabetize these would come later, right? Yeah.
Wait, does this explain again why the one with the 2000 is true?
This one?
Yeah.
Because it's just looking at the 0 and the 0, then it looks at the 1 and the 3. Okay? So this is kind of like if you have a word ABZ versus ADB or something like that. Okay? It doesn't matter that the Z comes after the alphabet in B. The only thing is that you compare the B with the D here. Okay? Okay.
So you're not like comparing like all of them?
You're not comparing all of them. You're like just looking at in order. You do first element, then the second, and then the third. Okay, as far as we're alphabetizing, you know, letters and stuff. Okay. So yeah, like if you had the word cat and cod, okay, A comes before O, so cat gets alphabetized before cod, right? But even though D comes before T, that doesn't matter because it just looks at the first 2 letters. Okay, there's a handy little idiom with tuples that just allows kind of like assignment. So if you had like letter values A and B, and you weren't going to use a tuple, and if you wanted to have B equal to 5 and A equal to 1, you'd have to temporarily store A into a temporary value, right? Because if I didn't have this, if I say A equals 5, B equals 1, and then I try to say, okay, well, let's make B equal to A, and then A equal to B, okay, what's going to happen? Everything is going to end up having the value of 5, right? if I say print A, and then print B, they're both going to have the value 5, because as soon as you try to swap the values and I say A equals B, then that happens, right? So if you want to swap them, you have to kind of store A into a temporary value. You set A equal to B, then you set B equal to the temporary value, and that allows you to kind of switch the values. So A is now 1 and B is equal to 5. But with a tuple, you can just do it directly. You can do A is 5, B is 1, and then you can swap, and you can say, take the values B and A, and give them the values A and B, right? And so this allows you to kind of just swap values directly, which is really nice. Okay, because what's happening is that as Python reads these, it says, okay, we're gonna have, it reads left to right and says, okay, we're gonna need a value for B, we're gonna need a value for A. And what am I gonna put into these things? And then it looks up the object associated currently with A and the object currently associated with B, kind of looks at those and says, oh, those are gonna go into B and A. So that's what it's doing. You can take, sometimes you have functions that return multiple values, okay? And you can capture those values. So normally, so let's say I have this, this is my email address, and you want to kind of split it, okay? You want to split it to the part before the @ sign and the part after the @ sign, okay? And so the result of this function, address.split, returns a list containing 2 elements, okay? And it's, so we're going to get this. Or, I mean, split, if you had a whole bunch of @ signs, it'll just produce a list containing a bunch of these things. And so the result of this is we get a list of 2 elements. And what we can do is we can take the result and assign it to a tuple, right? And so now I can say, take whatever this is, and then assign it to these objects called uname and domain. And it does that. And so yeah, now uname contains string Miles Chen, and domain is going to contain the string for the stat.ucla.edu, right? So we're not, so this again, even though I'm not explicitly creating a new tuple or something, Python uses a tuple as far as like this implicitly creates a tuple. The fact that I have two names here separated by a comma, Python recognizes that this is a tuple, and it recognizes that whatever elements we have here needs to get assigned accordingly. If this function returns 3 things, then I would get an error. Okay, so if I say split on the character E, okay, if I split on the character E, okay, I would get 4 elements. And if I say, all right, try to do this, okay, I would get an error. It says, because Python, again, reads left to right, and it says, okay, I've got a tuple with 2 things here. And then so whatever this comes back with, I'm going to take those 2 things and assign it. And then it's going to say, hey, wait a second, this thing on the right-hand side, it's got 4 things, okay? Right? It says too many values to unpack. I expected 2, because I'm seeing uname and domain. I expected 2, and I got too many things. So that, it gives you an error there. So, whoops. @ sign. All right, so that works out. Okay, so we basically use tuples when we return, if we want to return multiple values. So in a function, if you you use the statement return to have the function output something. So this is what would we call this? This is a divide function that's going to return. I don't remember what is it. What you have the remainder, and what's the other part? You have the divisor, the dividend, and then you have the quotient. But then if you do something with the remainder, what's the other part called? I don't know. Anyway, here I have it, the integer. But you have the integer component of the quotient, and then the remainder quotient portion. Okay, and then so here we do floor division. That's that. And then we do mod over here, the percent sign. And so we can do x divided by y. So if I do 23 divided by 5, that's going to be 4 remainder 3. And so this is going to return the integer and a remainder. And so here, j is going to be the tuple containing 4 and 3. Okay, a tuple of length 2. I get 4 and 3. Okay, but I can also take this thing and I can split it up and assign it to a and b. All right, and a is going to be 4 and b is going to be 3. Okay, and I defined this thing, but there's already a function called divmod that's part of base Python, and it does exactly this. Okay, there's only 2 methods that tuples have kind of built in. Tuple.index and tuple.count. And these work the same way as index and count do for lists. So I don't know if we remember what index and count do for lists. This is kind of the failings of using lecture to kind of teach code, is like, you got to write the code yourself. So that's what the homework's for. That's what the data camp homework is for. But I don't know. I also encourage you, after a lecture, you have this notebook, just start kind of fiddling around with it. Try new stuff. Okay. All right. So what does so if I create a tuple, what does index do? Index dog. What's this going to return? It's going to return the index of the first instant. So in this case, it's going to give us the number 4. It's going to say dog is at position 4. All right. What about 5? It is going to search for, in this case, string 5. How many times does string 5 appear? It appears once. Okay. All right. If I do tcount and I get rid of the quote marks around it, it's going to look for integer 5. How many times does integer 5 appear? Integer 5 appears twice. Okay. T-index gives us the index of the first instance of it. So t-index integer 5 is going to be 5 as well, because it's index position 5. If I do quote 5, it'll be, I think, is that what, 7? Yeah, no, 6, 7, 8, index position 8. Okay, so we have index and count, and basically it's going to look for whatever you give it and try to look for it inside the tuple. Let me see if, let me just try something. T-index, so if I give it a tuple here, and I say, look for cat and dog, is this going to work? I don't think so, right? It says this thing is not in there, because it just looks at one element at a time. Okay, count here. It's going to say that appears 0 times. Pretty sure there's no get. Okay, you have index. Okay. I don't think there's find either. Yeah, no find. Just index and count. Okay. These functions, length, sum, sorted, min, max, these are functions that run on basically any kind of iterable object. So that would be lists, tuples, dictionaries, strings, things like that. Okay. So here I've got a tuple of digits. I've got a list of words. And we can do things like, what's the length of this tuple of digits? And I'll tell you how many elements are in there. 1, 2, 3, 4, 5, 6, 7. What's the length of this list? Okay, that would be 5. Okay, the sum of some digits, it's going to take those numbers. I think this only works if you got numbers, and it'll add them up. So that's no surprise there. If you try to do it on strings, it's going to say, I can't do that. I can't add these things together. Okay. With some words, there's no integers in here, but then when I say sum of some words, it's interesting. It says unsupported operand type for plus, integer, and string. Basically, it's starting off with like a 0 integer, and then it's adding numbers to it, and it says, well, I can't do this. Okay. You can also take a tuple and you can sort it using the function sorted. Okay. Now this function sorted returns a new object that's the sorted version of the tuple. It doesn't actually modify the tuple itself. Okay. And then, I'm sorry. What it returns is actually a list. So it's not the tuple sorted. It's a list of the elements in the tuple sorted. Sorry. Okay. So the object returned is a list. Just to kind of show that the digits are unchanged. This is in their original order. And again, digits themselves, once you create a tuple, it's like writing it in pen. It's not going to change. This object, some digits, okay, as long as it's associated with that object in memory, it's always going to be the exact same thing. Now we can reassign something new to some digits, but whatever this object is, it's always going to kind of be the same thing. If you apply it to a list, it'll alphabetize the list. Minimum will give you the smallest value. Max will give you the biggest value. If you do max on strings, it'll basically say what's going to come last in the alphabet. And again, it uses the ASCII table to define the order of the characters. Okay, so all of the capital letters come before all of the lowercase letters, stuff like that. The digits are in kind of or the symbols are in a weird order that I never remember, but there's a table that applies here. Okay. All right. So here's a brand new tuple. Okay. And then if you try to sort this, because I've got a mix of integers and strings, this doesn't work. Okay. Here I have two dictionaries. This dictionary, the keys are numbers and the values are strings. And over here, the keys are letters or strings and the values are numbers. So the length of the dictionary is how many items are in the dictionary. So both of these dictionaries have a length of 3. Sorted takes the keys and it sorts them. Okay, so it's going to just take the keys and give you a list of the sorted keys. And then max is going to give us basically what's the last value of the key, okay, or the maximum key. Basically, like if you had sorted them, what's the last one that's going to come? So in our case, we'll get the number 3 there. Okay, let me give you some view quiz answers. Today is week 3, Wednesday. Okay, first one is B as in bear. Second one is A. No, yeah, A is an apple. B and A. I just watched this video on the NATO phonetic alphabet, like Alpha, Bravo, Charlie, and like the history behind it. Anyway, I don't know why I'm telling you this. It was interesting. I thought it was interesting. So Bravo, Alpha, I guess would be our first 2 letters here. Okay, all of our operators, not all of our operators, all of our iterable objects, lists, tuples, strings, and stuff like that. Okay, I guess not dictionaries. All right, but lists, tuples, and strings, a lot of these things support mathematical operators like addition and the multiplication sign. And multiplication basically duplicates and appends together, and addition just appends. So here I'm going to create 2 lists, L1 and L2. All right, L1 is ABC, L2 is DEF. If I do L1 times 2, I'm going to get ABC, ABC. L1 plus L2 takes these 2 lists, appends them, joins them together. Okay, and we get that. Here I've got 2 tuples, the same kind of thing, T1 and T2. T1 times 2 creates a new tuple with ABC, ABC. T1 plus T2 takes the two tuples, joins them together. So we're going to get ABCDEF, a new tuple with that. Okay, so these are all just brand new tuples that they're creating. You know, in the same way that if you take things, you know, you're doing that. Okay, so sometimes students might get confused because if you do something like this in R, and you do this addition, you would expect 101, 202, 303, right? You'd expect 1 gets added to 100, 2 gets added to 200, and 3 gets added to 300. That's how it would behave in R. But in Python, these are two lists. We're adding them together, and so we're going to get a list of 6 elements: 1, 2, 3, 100, 200, 300. Okay, so that's what you would get. There is, if you want to do 1, 2, 3 plus 100, 200, 300 and get 101, 202, 303, you have to use a different data structure. We use what's called a NumPy array, and that would support that. Okay, and that's future lecture. Okay, but this is just be mindful, right? This is not how R behaves when you add vectors together, but these aren't vectors. These are Python lists. Okay, you can't add a list and a tuple together. It says that's not allowed. Okay, but what you can do is if you do want to add a list and a tuple together, and when I say add, I mean join them together, concatenate, or append them to each other. You can always take a tuple and convert it to a list, and then you can take that resulting list and append it to L1. Right. So if I do L1 plus this, then we get that. Okay, so that's fine. Okay. With a tuple, okay, we can pass multiple arguments as something called star args. Okay, so we have these, I guess we call them variable length arguments, and it allows you to kind of pass multiple things as one. So here. So functions can take a variable number of arguments. A parameter name that begins with a star, what it does is it's going to gather the arguments together into a tuple, okay, and then use that as basically a tuple coming in. Okay, you can use anything, any name, and it could be star, you know, star names, star whatever. The traditional thing is going to be star args. Okay, and that's frequently what we have. And then you can also gather things into a dictionary, and that's called star kwargs. But anyway, this is just a regular old function where I have args. When it's just a regular parameter or argument, here Python expects one object. Okay. And so print all here, if I try to run print all and I give it multiple things here, okay, it's going to error out because it's saying I'm expecting just one thing called args, and I'm gonna try to print that out, and it says that, you know, I expected 1 and you gave me 4 things. I don't know how to do that. Okay, now if I do print all star args, it says, hey, if you give me a bunch of things, I'm going to gather them together into a single tuple. Okay, and then in that case, it's just I'm going to print out that tuple. Okay, but I mean I can also do, you know, print type of what is this? Okay, and so when I do this and I pass object 1, 3, 5, and high, it says that's a class tuple, and then it's printing it out as a tuple. Here, let me actually print a few things. Okay, I'm going to print the length of args. Okay, and so if I have that, it says that's a length 4, and then I can pass more things, right? I can do 0 and 12 and cats, and I can even put in a list itself. Okay, And so now it just gathers all of these things together into a single tuple, okay? And it prints out the resulting tuple there, okay? Here I've got 3, and even though I gave it only just one thing, because of the star args, it basically takes whatever comes in and it makes a tuple out of it, okay? And so it's still going to be a tuple, class length 1, and there it goes, okay? So here I can take multiple arguments, star args. It's going to gather them into a single tuple, and then I'm going to iterate through each element in the tuple, okay? And I can say, hey, take whatever that element is, capitalize it, and let's print it out. Okay. And so if I do this and I do print, then it's gonna take this and run through each element here. Print lines, if I just give it the integer 1, okay, then it just gathers it together into a single tuple and prints it out. That's all. So it allows you to kind of pass multiple arguments in here. You can even have things other than just, let me see. Okay, so you can have like print lines, and then maybe I'll just, I'll create a argument called magic number or something, okay? And then we'll just do magic number times 100. This will be, we'll call this result, and then we'll maybe return the result. And then we'll, right. So here I'm going to do that, and then so I can do print lines, and then I can do 10, and then 10, 10, 10, okay? And then what it's going to do is it's going to print, it's going to take this one, assign it to magic number, and then everything else that comes in here, it's going to gather them together into the tuple, okay? So I can do this, I can say print the length of of our tuple args, okay? And I'll say print the tuple has this many items, okay? All right, so now I can do 10 and then A, B, C, right? And then we have this, right? So 10, A, B, C, 10, 10. It says the tuple has this many items, 5, and then it goes through each of those things, A, B, C, 10, and 10, and then it returns our magic number times 100, okay? So you can kind of make more and more complicated things. You're only allowed to have one thing in here that has star args. You can't have like 2 things of star args in there, okay? Because basically it just says everything remaining gathered together into a tuple, okay? And you can't do that with like, you can't say everything remaining gather into 2 tuples because it doesn't know how to do that, okay? But that's what we have it. Okay. You also have scatter, okay? And so scatter also uses a star operator, but basically it allows you to take a tuple of multiple items, and then you can scatter them across arguments, right? So for example, so remember this divide function, okay? With divide, it's expecting 2 arguments here, 23 and 5. The, what is it? The numerator and the denominator kind of thing, okay? We're doing 23 divided by 5, and so we have 4 over 3, okay? What if I create a tuple with, it should be 23 and 5, sorry. 23 and 5 here, okay? So here I have this tuple, 23 and 5, okay? If I try to throw this into my divide, okay, where I'm putting in 23 and 5, it errors out because it sees t as length 1, okay? And it's trying to assign, okay, that one object, a tuple of length 2 into x, okay? So it gets confused because it says this function requires two things, x and y, and you only gave me one thing, t, which was a tuple of length 2. I don't want that. But you can use star t, and what star t will do is it's going to take 23 and 5 and then scatter them. It's going to say, oh, I've got two elements inside my tuple. I'm going to scatter them across the arguments. So 23 goes to x, 5 goes to y, and now it works. Okay. So you use star args to take multiple things in the function and gather them together into one tuple that you can then use or iterate over inside the function. But you can also take tuples and pass them in as arguments into a function that exists, but you can scatter the elements of that tuple across the arguments. Okay. We've seen zipping before, okay? And zipping takes two iterables, a string, a list, whatever it is, and it kind of matches the first and the second and the third, and it kind of matches these together, right? It kind of zippers them together. And so here, if I take S is ABC and T is 0, 1, 2, and U is apple, banana, cantaloupe, okay, I can zip S and T together, okay? And I get a zip object. So this is, again, Python being lazy. It's not actually not helpful. So I can just say, hey, make a list out of this, okay? And it's going to create a list of basically tuples of A gets matched with 0, B gets matched with 1, and C gets matched with 2. Okay. You can also zip multiple things together. Okay. Pair, maybe it's not right. Maybe I should call this a triplet. Okay. And so here I'm going to do S, T, and U, and it's like, I don't know, you have stacks of papers and you're collating them together to make like packets of information or something. So you want to say, all right, take, the top element from S and then the top element from T and join it with the top element from U, and then do it with the next element, and so on and so forth. So we're going to get A, 0, apple, B, 1, banana, C, 2, cantaloupe, right? And we get basically tuples of these things. And so you can kind of zip together a whole bunch of these, right? So zip, if you look at the argument for zip, zip allows for a flexible amount of arguments. So there is internally, there's going to be a star, right? Zip supports star args because here I can run zip with 2 things. I can run zip with 3 things. I could run zip with 4 or 20 things, okay? If I create is there a fruit that starts with a D? Durian. Oh gosh, okay. All right, so if you try to do zip unequal things, it just ignores the, I think the last one, well, here, let me see. Let me try D and E here. Yeah, it just kind of ignores the unequal lengths, unequal nature of it. And so the extra ones left over, the E, and is there a E fruit? I don't know. That sounds like a new tech product or something. It just kind of ignores those. What's that?
Eggplant.
Eggplant? Is eggplant a fruit? Maybe botanically speaking, apparently there's no such thing as a botanical vegetable. All vegetables it's a culinary category, and there's not like a botanist would say there's no such thing as a vegetable. They're like tubers or stalks or leaves or something. Anyway. Okay, so zip objects these are iterators, okay? is a kind of iterator, which is an object that we can iterate through in a sequence. Iterators are kind of like a list, but unlike a list, you can't use an index to select an element from an iterator, and iterators are inherently kind of lazy, right? So if you want to see the results of a zip, you can throw it inside a list, okay, and we get that. Here, if you have sequences that aren't the same length, it's going to give you the length of the shorter one. So here I have Ann with 4 letters, Elk with 3 letters. It joins them up. Here I'm creating a new tuple. I'm sorry, a list of tuples, okay? And we can kind of iterate through this thing, and it's going to split, or it's going to do tuple assignment for each of these things. The first gets assigned a letter, and the second gets assigned a number, prints all of these things out, and it kind of iterates through them. So we get 0a dot dot dot, or dash dash dash, 1b dash dash dash, 2c dash dash dash. If you say for the item, so here I said take whatever t is and then split that into letter and number. If we just say for item in t, then it's going to be a tuple, okay? So if we print the item, we'll get the tuple a0a or a0, okay? And then we can get the number, we can extract out the number or whatever, right? So we'll get a0 and then 0, b1 and so on and so forth. If I have letter, number, fruit, STU, I can zip all of those together and iterate through them, and we get that, okay? The letter is A, number is, well, this is, okay, T got messed up. All right, the tuple is this, okay. And then you could do a whole bunch, all right, and everything's going to be interwoven. So I've got, E, there we go. I had already answered my question earlier. Dates and elderberries for D and E. Okay, so anyway, we have this, and we get that. This is a useful snippet of code that you can kind of take 2 iterables and see if there's kind of a matching element, all right? So here I've got, is there any kind of match between ABC and DEF? There's going to be no match. What about ABC and DEC? The C will match. That gives me back true, and so on and so forth. If I have ABCD and I do it with DCBA, that's going to give us no match, right? And then enumerate is a handy little function, okay? And it's kind of like zip, but you just give it one thing, and enumerate basically zips whatever you give it with a range object of the same length, okay? So as far as if I do enumerate morning, it's basically going to zip range, how many letters is this? 7, okay? And we're going to get 0M, 1O, 2R, 3N, so on and so forth, okay? So basically enumerate is like zip, but zipping it with a range object, just because that's such a common thing that we do, that we have a built-in function that just kind of takes, basically, you give it a list, and then it's like, right, give me, write down numbers, okay? So like number this list, okay? If I give you a shopping list, and then enumerate is just, go ahead and just write the numbers, 1 through however many you have. So if I say enumerate ABCD, I'm going to get a list of tuples here, okay? And it's equivalent as doing a zip with a range object. Okay. All right, the last bit, I'm out of time. Let me give you your last view quiz answer. D as in dog. D as in dog is your third view quiz answer. All right, so this last bit here is where you can use tuples as the key in a dictionary. So remember, the keys in a dictionary have to be immutable objects. Typically, we associate dictionary keys as integers or strings. They could be floating point numbers, but immutable objects. But you can also use a tuple as a key, okay? So what's an example where we'd want to do something like that, okay? Swap the keys and the elements. Okay, so here I've got All right, let me just kind of skip through all of this so you can kind of check through all of that. Tuples as dictionary keys. So let's say we have a function, all right, where, you know, if I give it two values, like an x and a y, and it computes the result, right? Just imagine your function is this really kind of complicated thing. Maybe it's like a sum, right? Like you do a Taylor expansion and you have to sum like 1,000 elements. And so each time you compute it, it takes a really long time to compute. So, you know, what we can do is we can create a dictionary where I've already computed the answer, okay? And we'll call these like known things, so that if I've already like computed this thing, I don't have to actually recompute. I can just kind of look it up using the dictionary, okay? And so in that case, using a dictionary, I'm using tuples as like the arguments going into the function with the corresponding value of the function could be useful. And so here, I'm creating a function x and y, all right? We're going to create a tuple out of x and y, and it's going to search for that tuple inside our known dictionary. And if it is, we'll print out the values already existed, and we'll just print out that result, okay? If the value isn't known, then we'll go through the computation. Here it's very simple, but you could imagine some kind of function where it is complicated. And so the first time my dictionary starts off with 0, 0, I do this, this already is known, okay? My known dictionary looks like this. I can say, all right, compute it for 1 and 2, okay? It says this value must be calculated, and it gets us the value 5, okay? The known values, now we have 0, 0, and 1, 2. Okay. And then I could say, all right, try out 1 and 2 again, and this time 1 and 2 is a known value. It already exists in the dictionary, and so it returns 5, okay? So this time, up here, it calculates it. Down here, now that I've already calculated it and stored it in the dictionary, it can just kind of look it up. Okay, anyway, thanks for allowing me to go over. We'll end here, and we'll see you guys on Friday.